Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the wave parameters. What are the different wave parameters? So we have discussed different parameters such as wavelength, amplitude, frequency, energy and wave number. These are the different wave parameter we have discussed in our previous lecture, as well as how that wave direction of the propagation of wave radiation, that also we have discussed. So today what we are going to discuss here, look at what is written on the blackboard: units of measurement for wave parameters. And these units of measurement for wave parameter, it is again significant or it is very prominent as far as these spectroscopic techniques are concerned, and these are the convenient unit in which spectroscopy is used. So that type of the things we are discussing right now. So let's begin with first one is a wavelength. Right? First one is a wavelength. Wavelength, and as we know that wavelength is represented by the symbol lambda, and it is the definition, the distance between two crest or trough is known as a wavelength. And a wavelength is measured in number of units depending on the type of radiation studied. Suppose we have 1 angstrom, 1 angstrom or 1 angstrom is simply represented as 1 raised to 0 and is nothing but as a 10 raised to minus 8 centimeter, or it is nothing but 10 raised to minus 10 meter. 10 raised to minus 10 meter. So that is the relationship of that angstrom, and this wavelength is generally measured, or the unit of that wavelength may be as angstrom or nanometer. You might be knowing 1 nanometer. Nano means is a very small, 1 to 100 nanometer, that is called as a nano. So nanometer is nothing but as we can represent simply 1 nm is called as a 1 nanometer. And how much is a centimeter? You can remember this relationship. 1 nanometer is nothing but as a 10 raised to minus 7 centimeter, or we can represent 10 raised to minus 9 meter. Remember this one. 1 angstrom is nothing but as a 10 raised to minus 8 centimeter. And 1 nanometer is nothing but as a 10 raised to minus 7 centimeter. If in an exam, how will you convert the nanometer into angstrom or angstrom into nanometer? Now here just tell me 1 angstrom is equal to how much is a nanometer? Suppose as a, let me give one example over here. 1 angstrom is equal to how much nanometer? Can you tell me? 1 angstrom is equal to how much nanometer. So remember this angstrom, we know that how much is a centimeter. Suppose if you convert into as a centimeter, so 1 angstrom is nothing but as a 10 raised to minus 8 centimeter, right? And here also 1 nanometer, let us consider here is a 1 nanometer is nothing but as a 10 raised to minus 7 centimeter. So for convert into as a minus 8 centimeter, you should divide by 10 over here, right? 10 over here, and then here also as a 10. So what is going to happen? Therefore 1 angstrom is nothing but the 0.1 nanometer. This is the relationship you should remember while converting. 1 angstrom is nothing but as a 0.1 nanometer, that you have to remember over here. Means 10 raised to minus 8 centimeter is equal to 10 raised to minus 8 centimeter. That is a relation. If you divide by here, it goes above 10 raised to minus 1 plus minus 7 becomes as a minus 8, and therefore divided by 1 divided by 10 is nothing but as a 0.1. So this is the relationship. In this way you can convert one of the unit into as another unit. Now let us see as a 1 micron. 1 micron is nothing but as a 10 raised to minus 4 centimeter is nothing but as a 10 raised to minus 6 meter. This is also as a one of the relationship you should remember, and these are the different unit used in a different region, or what we can call it as in a particular wavelength. The unit of that wavelength, it may be represented by angstrom, or it has a nanometer, or it can be a micron. Micron generally represented 1 this similar to as a micron means nothing but as a 1 symbol is this 1 micron is equal to 10 raised to minus 4 centimeter, or 10 raised to minus what we can call it as a here. Simply remember here, let me give this clearly. 1 micron symbol, this is the symbol of micron, is 10 raised to minus 4 centimeter is nothing but as a 10 raised to minus 6 meter. So that are the symbols of this unit we have learned over here. Meter, small m you can represent over here, centimeter also as a small c and small m. So when we work in the UV, do you know the full form of UV? UV means ultraviolet. UV means what? Ultraviolet and visible region. When we work in the UV and visible region, the angstrom and nanometer unit are more convenient. When you work in UV and visible, if you work in UV and visible, the angstrom and nanometer unit are more convenient. When we work in the infrared, region, the micron is more convenient unit of measurement, and there you can use as a micron, here you can use as a angstrom and the nanometer. Angstrom always represented by a raised to 0, or just like as a degree we are writing, so a raised to 0, and the nanometer if you work in a UV or visible region. If you work in a IR, then micron is a suitable unit of measurement or for measurement. So this is all about the wavelength we have seen over here. Now let us discuss the second parameter, just now we have seen that the parameter, the unit for wavelength we can use as a angstrom or nanometer or micron. These are the different unit in the different spectroscopic technique. Then second will be the frequency. Second one is the frequency. Second will be the frequency, and frequency is represented by mu. And what are the units of that frequency? And frequency is measured in either hertz or cycle per second. Frequency is measured, or the unit of frequency is either hertz or cycle per second. That's it. And therefore 1 hertz, and therefore 1 hertz is equal to 1 hertz, Hertz, not Hertz. 1 hertz is nothing but as 1 cycle per second. 1 cycle per second, or in short we can represent 1 hertz is equal to 1 CPS, 1 cycle per second. Then 1 kilohertz, 1 kilohertz we can represent in the bracket, that is kilohertz is nothing but as a how much, that is 10 raised to 3 hertz, that is a 10 raised to 3 hertz. 1 kilohertz is equal to 10 raised to 3 hertz, or 1 megahertz, or 1 megahertz is nothing but as a 10 raised to 6 hertz. 1 megahertz is nothing but as a 10 raised to 6 hertz. And these are the means that frequency we can, the unit of frequency will be hertz or CPS, cycle per second. These are the conversions, you know that. And now next one we are going to see this hertz or cycle per second, kilohertz or megahertz we can represent. These are the unit of frequency. And now the third one is a wave number. Third parameter will be the wave number. Third parameter is a wave number, and which is represented by mu bar. Is measured in terms of number of waves per centimeter, or we can represent as a per centimeter, or we can call it as a K-sir, K-sir, K-A-Y-S-E-R-S, K-A-Y-S-E-R, K-sir, or in bracket you can represent as a K, where 1 K-sir is equal to 1 per centimeter, where 1 K-sir is equal to 1 per centimeter. So that is the relationship between K-sir and the per centimeter, and means the wave number we can represent it, or the unit of wave number will be per centimeter, that you can remember over here. Now let us move on to the next one. Next is energy. Fourth one, will be the energy. Fourth one will be the energy, and which is represented by represented by capital E. And energy is measured in ergs or joules. The energy is measured in terms of ergs or joules. Really, yes, joules. And as we know that the relationship between erg or joule means, therefore 10 raised to minus 7 ergs, 10 raised to minus 7 ergs is nothing but as a 1 joule. Remember this equation, 10 raised to minus 7 erg is nothing but as a 1 joule. So this is the relationship between that energy, means energy is represented by ergs or joule, joule. So remember, these are the unit of energy. And next point we are going to discuss the types of electromagnetic radiation. What are the types of electromagnetic radiation? The units just now we have seen. What are the unit? These are the main 4 parameter which we are frequently using while studying the different spectroscopy. Now let us move on to the next point. Next point we are going to discuss here is this one. What is that? Let us see over here. The next point is the types of electromagnetic radiation. B point we are learning types of electromagnetic radiation. Types of electromagnetic radiations that we are, what type of the, and because at the beginning we are defining spectroscopy is nothing but as the interaction of electromagnetic radiation with matter is known as a spectroscopy, and therefore it is essential to study the nature of the electromagnetic radiation, what type of the radiation involved in each type of the spectroscopy that we are discussing here. The electromagnetic radiation are classified on the basis of their wavelength or energy into different categories. Remember, the electromagnetic radiation are classified on the basis of the wavelength or energy into different categories. Now let's see over here one chart I am representing here. So let's see here this chart carefully, then you can remember. This is one of the chart I am drawing here. Suppose the 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is the 10 reason I am making over here, so that let me count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Right. Now this is one of the reason. Another reason. Here one more reason. Here also as a reason. Here I am representing. These are the some of the reason. Now according to that, we know that energy and wavelength, they are inversely proportional to each other. So what is this? This is a standard equation, remember here. So E is inversely proportional to wavelength. Let's see here. Here the above I am showing as a wavelength. Here wavelength, and at the bottom side I am showing as a energy. That is a energy, right? Energy denoted by E, and where lambda is represented by E. And now suppose here I am talking here is a low lambda. So at this end on the left hand side, what is going to happen here? Very high energy. Here we are going to get is a high energy, right? On this side is energy is increasing, and on this side wavelength is increasing. Here is a high lambda. Here must be as a low lambda, low energy here, low energy. What we decided, this representation on the basis of this, because energy and the wavelength, they are inversely proportional to each other. Now these are the reason on the basis of that wavelength is represented by nanometer, and therefore here is a this one, here is a 10 raised to 5, 10 raised to minus 5, 10 raised to minus 5 is the energy here. All are shown in the nanometer. These all are represented in the nanometers. All are represented in the nanometer. Remember here 10 raised to 5 minus 5 nanometer. This region is a 10 raised to minus 3 nanometer, and this region becomes as a odd number 0.1 nanometer. This one is a 100 nanometer. This should be a 400 nanometer. This one is a 800 nanometer, and here onward 10 raised to 5 now is a positive 10 raised to 5 nanometer. Here is a 10 raised to 7 nanometer, 10 raised to 9 nanometer, and 10 raised to 10 nanometer. Here is one option is there, 10 raised to 10 nanometer and 10 raised to 11 nanometer. That all are shown in the nanometer region depending upon that wavelength, right? Now what will be the reason here? As we know that this is a cosmic rays. This is a cosmic rays. Cosmic rays are very hot rays because they are having as a very high energy penetrating and causing. It is a very harmful, and therefore why? Because they are having as a very high energy. Cosmic rays. And now before that, this one is a gamma rays, as we know that gamma rays, then 0.1 to 100, that is a x-rays, as we know that. And after that 100 to 400, this region, this narrow region is known as a ultraviolet region. And now look at 400 to 800 nanometer. It is a very again narrow region is known as a visible region. This one is a visible region because those things or the object fall in this region we can see our naked eye, and those are beyond this region or above 800 nanometer, that object we cannot see by our naked eye. That is a region word. Now visible region, and after that is called as a IR region. This should be the IR region. This one is a microwaves. 10 raised to 5 to 10 raised to 7 are the microwaves. Then this one is known as a radar. This one is known as a radar. This one is known as a TV, and this one is known as a radio. Radio waves. Radio, that is NMR. Radio in bracket you can write NMR. So look at here. These are the 10 reasons cosmic rays, they are very harmful because there is a high energy is there. If you look at as a here TV, so wavelength is a very high, energy is a very low, and therefore it is not harmful to the living organism. For example, we are using as a mobile phone, we have a TV set, or what we can call it as a radios, and because the wavelength is a very high, suppose consider from here to Ahmednagar, so that much wavelength is there, but energy is a very small, and it does not cause to the human being or the object. But if you look at here, the cosmic rays or gamma rays or X-rays, you know that for the to investigate or to find out the defect in the bone, we are generally taking as a X-ray, and these X-rays are very harmful because X-ray is not if that gamma rays, pregnant ladies, so we cannot take the X-ray because that can harm to his little baby inside, and therefore these, because the energy of these are very high, and due to this reason we cannot take X-ray. So these are the and NMR radio waves, and these are the very low energy, very little bit energies are there, and therefore it is not causing, and that's why we are carrying the mobile with, and nowadays every person has a mobile, and therefore that are the application, what we can call the day-to-day lives application we are using in the spectroscopy. So this classification shows that cosmic rays have the shorter wavelength, hence highest energy and frequency, and radio waves have the longest wavelength, hence lowest energy and frequency. As we move from left hand side to right hand side in figure, the wavelength goes on increasing, and hence energy and frequency goes on decreasing. That is a general trend observed here. We also see that human eye can recognize the color of radiation in the region of 400 to 800 nanometer. 400 to 800 nanometer, which I already told you that only nanometer only, which is very small region compared to the whole spectrum of electromagnetic radiation, and this region is called as a visible region. We can observe, we can see the object directly, those are falling in that region 400 to 800 nanometer. That is the region. This region is known as a visible region. Why visible? We can see the object or the thing or the matter which is available. So like as a duster I am looking here, mobile or whatever cameras, or this chalk box or chalk table or benches I can see, so that are falling in the 400 to 800 nanometer, and that's why this is known as a visible region. In spectroscopic method, ultraviolet, visible, infrared, microwave and radio waves are generally employed. These are we are going to study, which are ultraviolet spectroscopy, visible, IR, microwaves and the NMR. Rest of the what we can call it as a reason we are not going to consider over here. And in when we say light waves, it generally implies the visible region, and if we use the word radiation, it implies anything that range from cosmic rays to the radio waves. Thus light waves are electromagnetic radiation in the visible region. So I think we have learned so these things. So in the next lecture we are going to discuss about interaction of the radiation with matter, because at the beginning I already told you that in the definition the interaction of electromagnetic radiation with matter is known as a spectroscopy, or when the spectroscopy, the electromagnetic radiation strike to the molecule, the responses are given by the molecule, are recorded in the form of a graph, and the study of this phenomenon is known as a spectroscopy. I think with this let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.